Okay, welcome back. This is 7-3 lecture number 3 on percent composition. So um, this again is using your individual compounds to determine their percent by mass. So it's more of a mathematical function, but it does identify the chemical compound. So if you can remember all the way back to um, chapter 3, the beginning of chapter 3, when we talked about some of our fundamental laws of science and of chemistry. One was the law of definite composition. It said all uh, pure substances have a definite percent by mass of each of those elements in that compound. So this is really what we're doing here. We're just going to be calculating that. Okay, so um, the percent by mass, as you can see down here, is of each element is known as the percent composition. So how we determine that percentage is just taking the mass of the element that's in the entire compound and dividing it by the mass of the compound, then multiplying it by 100. So really, we're just finding a percentage of each of the elements. Sometimes you're asked for all of the elements if you're just asked for the percent composition, and sometimes you are asked for just one particular element. Okay, so, and then lastly, we're going to do what's called a recovery problem, which uses a percentage that you find of a particular element. So let's just get into our first sample problem. So this says find the percentage composition of copper 2 hydroxide. So when it just says percentage composition, we will be finding the percentage of each element. And what you can do is when you're done, you can add up all of those percentages, and it should be very close to 100. It should actually be 100, but with rounding, sometimes it's a little bit off, but that kind of shows you that you are correct in what you're doing. Okay, so the first thing we have to do here with copper 2 hydroxide is from this name, write the formula. So copper 2, remember that would be Cu plus 2. Hydroxide is one of your polyatomic ions. That's OH minus. So we have Cu plus 2, OH minus. So when we write that substance out, it is going to be Cu and then the whole quantity OH. OH taken twice. Okay, so CuOH taken twice. So what we need to find out here first is what's the mass of this entire thing, because that's what's going to go in the bottom. And then we'll divide each of our masses by that. So for the formula mass, let's just write that out. And for these, it's good to write it out because you're going to be using those anyway. So in copper 2 hydroxide, we have 2 hydrogens, 2 oxygens, and a copper. So copper is 63.55. That's its molar mass or its formula mass. Okay. 2 oxygens, as you can remember, oxygen 16, hopefully. So that's going to be 32.00. Ooh, that was about a 32.00. And then lastly, 2 hydrogens, 1 hydrogen being 1.01. Your 2 of your hydrogens are 2.02. Okay, so we're going to add that up and get a total. So this will give you 97.57. Okay, 97.57. So that gives you your total. That's in grams per mole. Remember that atomic mass units. There we go. Okay. That's not like a good looking gram per mole, but that's what that is. 97.57. So to find our percent composition, we have to find our percentage of each one of these elements. So for our percentage of copper, okay, your percentage of copper, if you look back at that previous screen, that's going to be your mass of copper, 63.55, divided by your total mass of your compound, that's your 97.57, and then we're going to multiply that by 100. And this will give you your percentage of copper. Sig figs are not that important with these. I usually round it to 2 decimal places. So let me pull up my calculator here. 63.55 divided by 97.57 times 100, and I get like 65.13%. So 65.13%. Okay, so this compound by mass is 65.13% copper. Now for your percentage of oxygen, okay, take your total. Whoops, I'm getting ahead of myself here with these buttons. Okay, so we're going to take 32 and we're going to divide that by 97.57. We're going to multiply it by 100. And we're going to get a value. Okay. So let me do that real quick. 32 divided by 97.57 times 100, 32.80%. Okay, so it's 32.80% oxygen. One way you could find hydrogen here, you could subtract these two from 100, and that should give you the remaining percentage of hydrogen. Excuse me. I'll just write it out real quick for you. Percentage of H. Okay, so that's going to equal 2.02 divided by 97.57 times 100, and that's going to equal, so 2.02 divided by 97.57 times 100 is 2.07%. 2.07%. Make that 2 a little better. There we go. Hydrogen. So if you add these all up, you do get 100%, which it should. It should be close. Sometimes, like I said, with rounding, it won't be that. But that's your percent composition. So any sample of copper 2 hydroxide is going to have this percentage by mass. So you're just taking your mass of your element in the compound, dividing it by the total mass, and then multiplying by 100. Okay, so let's look at this next one. Find the percent of oxygen in calcium sulfate. Note, you just have to find the oxygen. You don't have to find the calcium and sulfur that's in here. First thing we have to do again is write the formula out. Calcium is Ca plus 2, sulfate SO4 minus 2. So calcium sulfate is going to be CaSO4. Plus 2 minus 2. There's just one of each. Okay. So we still have to find that mass. So 1 calcium. Calcium's 40.08. Okay, so we'll put that there. Make my 8 like that. How's that? 1 sulfur. Okay. Oh, that was bad. 32.07 is sulfur. Okay, these are just coming from the periodic table. And then 4 oxygens, that's 16 apiece. That'll give you 64. Okay. We're going to add those all together. So 40.08 plus 32.07 plus 64, that's like 136.15 grams per mole. And that's the mass of the compound. Now, it's nice here, we don't have to go through and do each one of these. We just have to do the oxygen. So to get the percent of oxygen, okay, We just have to take the mass of oxygen in the compound, 64, and divide it by the total mass of the compound, which is 136.15 times 100. And that's going to give me an answer of, here we go, 64 divided by 136.15 times 100, like 47.01%. 47.01% of oxygen in that compound. Okay. So that's it. You don't have to do the other ones. Okay. Just have to go through and do the oxygen. All right. And lastly, now this is called a recovery problem. And I'm just going to kind of verbally talk about how we're going to do this, then go through and do it. So it says how much gold can be recovered from 500 grams of gold-3 chloride. So if you have a gold compound like gold-3 chloride, AuCl3, and you can extract the gold. There'd be a chemical process to extract the gold from gold-3 chloride, and you want to know how many grams of gold you would have from this 500 grams of this gold-3 chloride. This would be like a gold ore that you would have. And so what we're going to do is we're going to find the percentage of gold in this gold-3 chloride and then find out what that percentage would be of 500. So, for example, if this gold-3 chloride by mass is 50% gold, then you're going to end up with 250 grams of gold from the 500 grams of gold-3 chloride. So that's really what we have to do. It's not going to be a perfect percentage like that, but we do have to figure out what is the percentage of the gold in here, then find out what percentage that is of 500. So with gold-3 chloride, we have 1 gold. Okay, that's Au. And that's going to equal, gold's a pretty massive compound, 196.97, or an element, I said compound, excuse me. It's a pretty massive element, 196.97. And then we have 3 Cls. Okay. And that's going to be 3 times 35.45, which is 106.35. So 106.35. We'll add that together. So that's going to be plus 196.97, 303.32. Okay, 303.32. Okay, so this is our mass of our compound and the mass of our individual elements. So what we want to figure out is what is the percentage of gold in there, okay, and just gold-3 chloride in general. So that's going to be, just as we just did, 196.97 divided by the total, which is 303.32 times 100. And that's going to equal, so let me see what this is going to be, 196.97 divided by 303.32 times 100. So it's going to be like 64.94% gold. 64.94% gold. Okay, so that's our percentage of gold. Now we have to figure out, well, what is 64.94% of 500? Well, mathematically, to do that, we have to take our 500 and multiply it by the decimal of the percent. So we're going to take this 500 and multiply it by 0.6494. That's really the ratio that this gold-3 chloride has of gold. So when we do that, we're going to get a gram amount. And that's going to be the gram amount of gold that is in gold-3 chloride. So I have to take 500 times 0.6494, and that gives me 324.7 grams of gold. Okay, so if you need to take a look at what we did here, this was nothing new. We found the percentage of gold, but the only thing we had to do there was take this percentage times your gram amount of your compound to get your gram amount of gold. Okay, so go back and see if you need to review any of these. Your homework has a couple of each, a couple just regular percent composition problems, a couple of where you just have to find one element, and then it does end with one recovery problem like you see here. It's very similar.